In this section, we got a couple of different types of polynomial division to look at. So the first type is what's sitting in front of us, dividing a polynomial by a monomial. And this is the easy type. Now, first thing I'm going to mention is that you notice that in both of these problems here, what's in the denominator is only one term. And so we can use this method because the denominator has only one term. If there was more than one term in the denominator, we cannot do this. So again, this only works because the denominator has one term. So I've got a 6x squared on the bottom. I got a couple of terms on top. Divide each term in the numerator by the term in the denominator. So take 6x to the fifth over 6x squared. And we're going to take 18x to the third over 6x squared. So in the first term over here, the 6's cancel. Look at the x's. I've got 5 on the top. I've got 2 on the bottom. So 2 of them cancel top and bottom. And I'm left with an x to the third, right? Or you could do it with the exponents. 5 minus 2 is 3. In the second term, 18 divided by 6 is 3. Look at the exponents. 3 of them on the top, 2 of them on the bottom. 3 minus 2 is 1. So I got x to the first. And that's my answer. I divided a polynomial by a monomial. All right, look at the second one. The second one also works because it's got one term on the bottom. It's got a 5a. So I take the 5a squared and divide it by 5a. I take the negative 8a and divide it by 5a. And I take the 10 and divide it by 5a. Now, the first one's the 5 cancels top and bottom. A squared on the top, a on the bottom, leaves me with just an a. Over here, an a cancels top and bottom, and I'm left with just a negative 8/5. The third term, I can take a 5 out of top and bottom, but that leaves me with a 2 on the top and an a on the bottom. So I can leave my answer like this. If the question said to write it without any variables in the denominator, then I could write it as 2a to the negative first. All right, look at the third one. For the third one, I've got y. So I got a y to the third on the bottom, and I've got other terms up on the top. So take your 16y to the fifth, divided by a 4y to the third. So maybe you don't have to write each one out now. Maybe you're starting to see how this works. 16 divided by 4 is 4. I've got a y to the fifth and a y to the third. 5 minus 3 is 2. 4y squared. Well, once we do it with the first one, now we got to do it for the other two, right? So just because you divided the first one doesn't mean it's gone. It still applies to the other two terms as well. There's a minus sign, so we'll carry the minus sign with us. 12 divided by 4 is 3. Now look at the y's. 4 up top, 3 down the bottom. 4 minus 3 is 1. Y to the first. Right, let's do it for the third term. 8 divided by 4 is 2. Now look at the y's here. 2 of them on the top, 3 of them on the bottom. 1 more on the bottom and the top. All right, so for each one, we'll take the terms on the top, divide them by the ones on the bottom. That's the simple case. The more challenging case is when you have something on the bottom, like a 4y to the third plus 6y or something like that, and then you can't use this method because there's more than one term on the bottom. So for that, we need polynomial division. So before I get into polynomial division, let's do a little bit of review of long division. Maybe you did this, I don't know, 4th grade, 5th grade? 758 divided by 6 using long division. So we've got 4 words: dividend, divisor, quotient, and remainder. So when we write this out, we could write it like this. 6 on the outside, 758 on the inside. So the dividend is 758. That's what we're dividing. The divisor is what we're dividing by. So we're dividing by 6. The quotient and remainder we won't know until we finish the problem. All right, so the first thing we do is we take the 6 on the outside. Is there at least one group of 6 in the first digit? Yes. All right. 7 divided by 6 is 1. 1 times 6 is 6. And we subtract. So 7 minus 6 is 1. Bring down the 5. Are there groups of 6 and 15? Sure, there's 2 of them. 2 times 6 is 12, and I subtract. 15 minus 12 is 3. Carry down the 8. Are there groups of 6 and 38? Sure, there's 6 of them, right? 6 times 6 is 36. Subtract, and I get 2. At this point, I have no other digits left. There's nothing else after that 8. So that 2 is my remainder. So the quotient is 126. The remainder is 2. So I can write it as 126 remainder 2. Sometimes we also write it as 126 and 2 pieces left out of 6, or even 126 and a third. The remainder always has to be less than your divisor, okay? Because remember, essentially what we're doing is we're taking 758 items and putting them into groups of 6. So I can make 126 complete groups, and I've got 2 left over. If I had 6 or more left over, I could make another group. So that number that we end with, the remainder, will never be more than the divisor. It turns out, by the way, that you can go back and check your work doing this. Take the quotient, multiply it by the divisor, then add the remainder. So you're saying I have 6 groups of 126, plus the 2 that are left over should give me back the 758 that I started with. All right, how about a longer number? How about taking 71 into 24,376? So let's see how many groups of 71 I can find in here. Well, first of all, there's not any groups of 71 and 2. There's not any groups of 71 and 24. I have to go to the third digit to find out. All right, so rough estimate, 24 divided by 7. Well, 21 divided by 7 is 3. So let's start with 3 as a guess. Notice I'm going to put the 3 on top of the 3 because 243, I need all 3 digits to divide into 71. So we're not going to put it across on top of the 2 or the 4. We're going to put it in the first spot at the end of that number. All right, so 3 times 71, 21 and 3. Subtract. I get 30. Notice the number is less than 71. We're good. Bring down your 7. Right, I'm going to guess 4. 4 times 1 is 4. 4 times 7 is 28. I'm going to subtract. 7 minus 4 is 3. 2, 3. Carry down the 6. Right, let's go with the 3. 3 times 1 is 3. 3 times 7 is 21. And I subtract. If I made a bad choice, then I would know because I'd get a number down the bottom instead of that 23. I get a number that's bigger than 71, and I know, oops. Or I get a negative number, which means I picked a number that was too big. So I have 343 with a remainder of 23, or 343 and 23 left out of 71. So my dividend was 24,376. My divisor was 71. The quotient was 343, and the remainder was 23. And I could check by taking 71 groups of 343 and then adding in my remainder. And that should give me back the 24,376 that I started with. So what does this have to do with polynomials? Well, it turns out we can divide polynomials with the same type of idea. So I wanted to do a couple by long division because, yeah, you could put these in your calculator, but you can't put these in your calculator. So we can do polynomial division in this way. The 2x minus 1 goes on the outside, and on the inside goes a 4x squared plus 6x minus 8. So what I do is I take the leading terms and I divide them. So the leading terms here are 4x squared and 2x. So I take 4x squared divided by 2x. 4 divided by 2 is 2. There's one more x on the top. So the first term that I get in my quotient is 2x. I'm going to line it up over top of the x's because that'll help me know when to stop the problem. Now, 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Now remember what we're doing is we're subtracting the top from the bottom. So we're subtracting the whole row, so we're changing this sign over here, and we're changing that sign over there. I put little circles around them when I change the sign. You can, you don't have to. Notice the x squares go away. That's good. That's what we want. 6x plus 2x is 8x. So I get 8x, bring down the next term, minus 8. Take leading terms and divide them. So 8x is a leading term on the bottom. 2x is a leading term as the divisor. I end up with 4. Again, we multiply. 4 times 2x is 8x. 4 times negative 1 is negative 4. Now remember, we're subtracting this row from the top. So change the sign. Change the sign. 8x minus 8x goes away. Positive 4, negative 8. I get a negative 4. So the answer is 2x plus 4. And then I can write my remainder as negative 4 over 2x minus 1. So just like we did with long division with numbers, we can do long division with polynomials. We get a quotient and then a remainder. Now, if it turns out that the remainder is 0, then that meant that 2x minus 1 would have been a factor of whatever was up on the top. And so we can check our answer, right? We can multiply the divisor times the quotient plus the remainder, and that'll give us what we started with. So we could take 2x plus 4 and multiply it by 2x minus 1, and then add a negative 4. And we should get back that line. And I will leave that for you to do. All right, here's another one. I'm going to do a few examples here because I know this is probably new for you. So I'll put the x plus 4 on the outside. (2x squared plus 9x plus 8 on the inside. So we start with the leading terms to divide them. So we take 2x squared, divide it by x, and that gives us 2x. So where do we put it? Not over the x squared term, over the x term, because that'll help us to know when to stop. 2x times x is 2x squared. That's good. 2x times 4 is 8x. Remember, we're subtracting this from the line above it. So we're subtracting, we're subtracting. The x squares go away. They should. If a term doesn't go away, if at least one term doesn't go away, then something's wrong with the way that you put that number up on the top, because we have to keep moving this thing forward by getting rid of a set of terms before we add the next one. So 9x minus 8x is 1x. Bring down the 8. Okay, if we bring down a term without having gotten rid of a term, we're just making the mess. So the leading terms are x and x. Oh, it's just a 1. 1 times x is x. 1 times 4 is 4. Remember, we're subtracting. So subtract, subtract. The x's go away, and I get a 4. So what's my answer? 2x plus 1 plus 4 over x plus 4. All right, maybe if we have a minute at the end, I'll come back to this and I'll show you how to do this with synthetic division. If you've done synthetic division before, you can use it in some cases. If not, don't worry about it. You'll see it again in pre-calc. All right, whoa, this one looks longer than the previous one. What do I do with this one? Same thing we did before. Start with the leading terms and divide them. So take 2x to the third, divide it by x, and I get 2x squared. So 2x squared goes over here, and I multiply. 2x squared times x is 2x cubed. 2x squared times negative 8 is negative 16x squared. Now, remember we said we're subtracting. So we're going to change the sign here. We're going to change the sign there. X to the thirds go away. Positive 16, negative 19, negative 3x squared. Bring down the 29x. Leading terms and divide them. So negative 3x squared is in front of the term on the bottom. X is in front of the term on the top. Gives me a negative 3x. Multiply. Negative 3x times 8 is negative 3x squared. Negative 3x times negative 8 is positive 24x. Remember we said we're subtracting, so we're going to change the sign. X squares go away. Positive and a negative zero out. 29 minus 24 is 5. Bring down the negative 40. Right, take the 5x and divide it by x, and I get 5. 5 times x is 5x. 5 times negative 8 is negative 40. When I change both those signs, I get a negative here and a positive there. Look at that. The whole thing zeroes out. So my answer is just this 2x squared minus 3x plus 5 at the top with no remainder, which means that x minus 8 is a factor of that third degree polynomial that's on the inside. So is the 2x squared minus 3x plus 5. So that's what it means. Okay, not the most important part of this. This is mostly just going through the process and procedures, but if you want to know what it means when you get a remainder of 0, that's what it means. Okay. This one looks a little different. Divide x to the third minus 12 by x minus 2. Notice that we're missing some terms in our dividend. We have an x to the third, but we have no x squared term and no x term. So what I have to do in that case is I have to put blanks in there. So I'm going to have an x to the third. I have no x squared. I have no x minus 12. Okay, and here's why we need to do that. Take the leading terms and divide them. So take x to the third, divide it by x, and I get x squared. Where does that x squared go? It goes above the x squared term. But if I didn't put the 0x squared, there wouldn't be an x squared term, right? There would be an x to the third and a 12, but no x squared term. So that's one of the reasons I put those placeholders in there of the 0x squared and the 0x, so I have somewhere to put my terms as I divide. So now let's multiply. X squared times x is x to the third. X squared times negative 2, negative 2x squared. We're going to be careful of signs. That's a minus, that's a plus. Third degrees go away. 2x squared plus 0x squared is 2x squared. All right, so from here now I bring down the next term, which oddly enough is nothing. Right? It's a 0x. But watch what happens. Take my 2x squared, divide it by x, and I end up with a 2x. So I put my plus 2x here. 2x times x is 2x squared. 2x times negative 2 is negative 4x. So there actually is a term that pops out of that. Subtract. 0x plus 4x is 4x. Now carry down the minus 12. 4x divided by x I can see is 4. So I get a 4x minus 8. Change signs. The x's go away. I'm left with negative 4. So my answer is x squared plus 2x plus 4 with the remainder of negative 4 out of x minus 2. All right, so that's what we do when we have gaps in there. When we have an x to the third minus 12, we're missing the x to the second term and the x to the first term, and so we have to compensate by putting in those zeros. All right, look at this one. Look at those terms on the top. I got a 5th degree, 4th degree, no 3rd degree, right? No x to the third, and no constant at the end. So here, I'll put my 3x to the third minus 2 on the outside. On the inside, 6x to the 5th, 9x to the 4th, no x to the thirds, minus 4x squared, minus 6x. All right, take my leading terms and divide them. So 6x to the 5th over 3x to the third. 6 divided by 3 is 2. 2 more x's in the top and the bottom. So this is going to go kind of quick. Where's our answer go? All the way over here. So 2x squared times 3x to the third is 6x to the 5th. and then minus 2 times 2 is 4x squared. All right, so double check. 2 times 3 is 6. That's x to the fifth. 2 times negative 2 is negative 4, x to the second. All right, we said we're going to subtract, so change signs. Change signs. The x to the fifth goes away. 9x to the fourth comes down. Those x squares go away also. So now how far do we have to go? Well, if we were to divide 9x to the fourth by 3x to the third, we'll get a 3x to the first. So 3x will be our next term, which means we're going to have an x come down, because otherwise we're going to have nowhere to put that 3x times negative 2. So what comes down? A 9x to the fourth. Nothing here, right? No x to the thirds. No x to the seconds. Negative 6x over there. So now take 3x times 3x to the third. 3 times 3 is 9, so I get a 9x to the fourth. 3 times negative 2 is negative 6, so negative 6x. And a funny thing happens. That goes away. I change that sign. That goes away. There's no x to the thirds. There's no x squares. There's no constants. I'm done. There's my answer. 2x squared plus 3x. And you notice what happens is there's no remainder. All right, you might want to pause this video and try the first problem up there, and then I will work it out on the other screen. All right, so this was the problem. Let's see how you did on it. Take the leading terms and divide them. X to the third divided by x is x squared. So when I multiply, x squared times x is x to the third plus 4x squared. Remember, we're subtracting, so subtract, and I end up with no x to the thirds. 2 minus 4 is negative 2. Bring down the 11x. Negative 2x squared divided by x is negative 2x. So I get a negative 2x squared minus 8x. Change signs, change signs. Positive 8, negative 11 gives me negative 3x minus 12. When I do negative 3x over x, I get negative 3. So negative 3x minus 12, and I can see I'm subtracting something from itself, so I just get 0. So I end up with x squared minus 2x minus 3 as my answer with no remainder. Now, I had mentioned synthetic division. Here's what synthetic division is. First of all, it only works if you're dividing by something like x plus 4, where it's an x to the first power, and that 4 is an integer. So what you do is you put the opposite of the number you're dividing by on the outside of a set of brackets. So instead of plus 4, I'm going to put a minus 4. Then I'm going to put all the coefficients here. 1x to the third, 2x squared, negative 11x to the first, negative 12. Draw a second line underneath. Bring down the 1. Multiply the negative 4 times 1, and I get negative 4. Now add the 2 and the negative 4, I get negative 2. Now take that negative 4 times negative 2, I get positive 8. 8 minus 11 is negative 3. Multiply negative 4 times negative 3, I get positive 12. Add them together, I get 0. So notice I got 1, negative 2, negative 3. I started with an x to the third. So synthetic division drops it down by a power, so that 1 becomes a 1x to the second, negative 2x to the first, negative 3 is a constant, and that's my remainder. So you notice I get the same answer that way too. All right, so I had mentioned synthetic division. If you've seen synthetic division, it only works if you're dividing by something like an x to the first. The previous example, we were dividing by an x to the third. Synthetic division doesn't work. So it works nicely, right? It's a quick way to divide polynomials. But if you like it, you can use it. If you don't like it, then stick with the regular polynomial division, and you will see synthetic division again when you get to pre-calc. All right, and that's it. That's polynomial division.